You're watching a Channel 98 NBISD TV production.
Hey, welcome to a milestone edition of That Geometry Show. As always, I'm your host, Kevin Corpy, and as you can probably tell from my face today that I'm very, very, very excited, and for good reason, too. Today marks the 100 divided by 10th episode of That Geometry Show, and we're all excited here at the staff at That Geometry Show for finally reaching the double-digit mark. It's quite an accomplishment. So to mark the occasion, we put a very special show together for you. We're going to be talking all about isosceles triangles today. We're going to kind of get into the realm of equilateral triangles. We're going to be looking at theorems and some postulates and even some corollaries. And as always, we're going to do a little bit of algebra and have lots and lots of fun. So download those documents from the district website. Please download those documents from the district website. It's www.newbraunfels.txed.net. And keep them out in front of you as I'm working along today, and hopefully you'll learn something. So let's proceed without further delay. All right, Lesson 10. Today's lesson is going to correspond with your Glencoe Geometry textbook. It'll be Chapter 4.6. We're going to be analyzing isosceles triangles. So by the end of this lesson, you should be able to do two things at least. Number one, you should be able to use the properties of isosceles and equilateral triangles and applying all the theorems. And you should be able to look forward to next week's show. Yeah, that's going to come naturally, I know. Okay, so you're probably saying triangles again, right? We've covered triangles the last 2 weeks. Well, we're covering it again this week, and we're going to be covering it again next week. Triangles are a very, very important part of geometry. But today we're actually going to be focusing primarily on the properties of isosceles triangles, which will naturally lead us into the realm of the equilateral triangle as well. So we need to start off by reviewing an isosceles triangle, what it is, and its parts. Okay? So an isosceles triangle, remember, has at least two congruent sides called the legs, and the legs are denoted, the congruent ones, by these little tick marks there, and a third side that is called the base. Now in this diagram here, the base is on the bottom, but remember the base is just opposite the vertex angle, and the other two angles that are not the vertex angle are called the base angles, and in an isosceles triangle, the base angles are also congruent. Okay, and we denote congruent angles by drawing one arc and congruent sides by drawing one tick mark. So that's what isosceles triangle in. We have two equal sides, or two congruent sides called the legs, and two congruent angles called the base angles. Remember that? Good. Now there are a few special rules to learn and to remember. Learning them is one thing, remember them is something entirely different. We need to remember them when we're dealing with the isosceles triangles. Now the following is a very important theorem called the isosceles triangle theorem. It's a pretty appropriate name since it deals with isosceles triangles. Here's what the theorem says. It says that if two sides of any triangle are congruent, well that pertains especially to an isosceles triangle, then we know that the angles that are opposite the two congruent sides are also congruent. So if I had this triangle here and I had any two sides congruent, let's say this side here and that side there, the theorem says that knowing that the two sides are congruent means that the side that's opposite, or the angle that's opposite, this one, and this angle that are opposite, these two angles right here, are congruent. Okay? Now we know that about an isosceles triangle. But this says for any triangle with two congruent sides that the angles are congruent. So how can we use this? Well, let's look at this example. We want to find the value of x in this triangle. Well, we know that two sides are congruent because we see the two tick marks right here. That means this side is congruent to that side. So by the theorem, we know that this angle, which has a variable expression 5x, and this angle here, which is not labeled, have to be congruent. And so if we know this one is 5x, we can label this one as well as 5x. Now that we have an expression or a number for all the interior angles of the triangle, we can use a theorem from a previous episode that said the sum of all the interior angles of a triangle have to equal 180 degrees. So writing the expression here, I get 5x, the first base angle, plus 5x, the other base angle that's congruent, plus 50 degrees has to equal 180. Now I can subtract 50 from both sides and combine my two 5x's to get 10x equals 130. And then dividing both sides by 10, I get x equals 13. So x is 13. Let's read the question again. It says to find the value of x. Well, I did find the value of x. It happens to be 13. So I've answered the question. Now, the question could be asking for what the measure of one of the two congruent base angles is. Well, then I would have to say the base angle is not x. It's 5 times x, which in this case, x is 13. So I'd get a different answer. I'd get 65 degrees. Okay, so make sure that you're answering the question. Okay, next example. What is the value of x? It's a pretty common instruction for a math problem. But notice in this case that x is this vertex angle up here. Now, how do I know it's the vertex angle? Well, I have two congruent sides. So this is an isosceles triangle. So these angles that are opposite the two congruent legs are the base angles. And in this case, we know that both of them have to be 58 degrees. And the vertex angle is the variable. Well, it's very similar to the above problem. We can add them all up. So 58 plus x has to equal 180. Now, whether or not I write the little bubble for the degree symbol, it's implied to be degrees. So we really don't need to write them. So 58 plus 58 is 116 plus x equals 180. And I'll subtract 116 from both sides. And when I do that, I get 64. Now again, x is equal to 64. Finding x doesn't necessarily mean we've answered the question. Let's read it. The instructions do say to find x, where x in this case is the vertex angle. So I have answered the question. The answer is choice D. Okay, so not too bad. We're using the isosceles triangle theorem. We're given two sides and we're finding angles. Here's another example. This one doesn't have a picture, as you can see. It's just a bunch of words, so we're going to have to draw our own picture. In an isosceles triangle, PQR, with a base of QR, we know that the measure of PQ is 2x plus 3, and the measure of PR is 9x minus 11. What is the value of x? So again, we're finding x. Well, let's go ahead and draw a picture. Any triangle will do. We just need to have something to label. Now I know that it is an isosceles triangle with a base of QR. I'm going to go ahead and establish my base because everything is going to be oriented from there. We don't have to draw the base on the bottom, but it makes sense to do so when we have our choice of drawing it. So I'm going to label this point Q and this point R. And then the other unlabeled point would have to be the third letter in the triangle, which is P. That helps us orient ourselves. So this is the base. And so then I know that these have to be the two congruent sides based on the definition of isosceles triangle. Well, now I know also that the measure of PQ, which is this one here, is 2x plus 3. And I know the measure of PR is 9x minus 11. Well, since I know that this is the base angle, these are the two congruent legs, which means these two variable expressions must have the same measure. They must be equal. So I can set those two algebraic expressions equal to each other. And now I have one equation with one unknown, so I can solve for the unknown. I'll go ahead and collect my x's on the right-hand side just so everything's positive. So if I subtract 2x, I get 9x minus 2x, which is 7x. And if I bring the negative 11 to the other side, it becomes positive 11 plus the 3 that were here. I get 14. Now I divide both sides by the 7, and I get x equals 14 divided by 7, which is 2. Have I answered the question? The question said to find the value of x, and in fact, I found x to be 2. Now, this question also could have said to find the measure of one of the two congruent legs. If that's the case, I would then need to take the 2 and plug it back into either one of these expressions. For instance, to find the length of PQ, I would get PQ, the measure is 2 times my x plus 3, which would be 4 plus 3, which is 7. And just to verify, if you have the time, you could say then PR is 9 times 2 minus 11, which is 18 minus 11, which should give us the same value of 7. So if you ever have time and you're solving for x, even if it doesn't ask you for the side lengths, you can check yourself to make sure that you found the right answer. Always a good habit to get into. All right. We've talked about the isosceles triangle theorem. Now we can look at the converse of the isosceles triangle theorem. Remember, the converse basically just interchanges the if and then part, the hypothesis and the conclusion. So instead of starting with two congruent sides, we're starting with two congruent angles. Here's what it says. If two angles of a triangle are congruent, like we know the base angles are in an isosceles triangle, then the sides that are opposite those two base angles or congruent angles are also congruent. So it's the converse of the isosceles triangle theorem, which by now you should realize that it is really an if and only if statement. So let's look at this example here. We have triangle DEF, and these two little red arcs mean that these two angles are congruent. So by the converse of the isosceles triangle theorem, we know that the measure of that side opposite this angle and the measure of that side opposite that angle have to be congruent, the same measure. So in the instructions it says to find x again. Imagine that. Well, I know since they're congruent, I can set them equal to each other. So 11 has to equal 2x minus 5. And adding 5 to both sides, I get 16 equals 2x. Dividing by 2, we get x equals 16 halves, or the number 8. And again, since that's what the instructions were asking us to do, to just find x, we know that the answer is 8. Now, here's another strategy for taking a multiple choice test. Since this is a number 11, and this is just a variable expression, and you're given 4 answer choices, sometimes it might be quicker just to actually plug in your answer choices into 2x minus 5 to see which one would give you the number 11. Okay, it's kind of back solving, and you can do that when you have numeric answer choices. So plugging in an 8 for 2x minus 5 would give you 16 minus 5, which is 11, and you know you'd found the right answer. So just another strategy that's available to you. All right, one more example, and I think it's time for a break. There's a lot of examples today. Here's another triangle. This one is not labeled on the vertices, but we can see that these two angles are actually congruent because they have the same arc. Well, we want to find the value of each of the two sides opposite the congruent angles. So I know by the converse of the isosceles triangle theorem that this side opposite that angle and this side opposite that angle are congruent. So they're both variable expressions here, but I can set them equal to each other. So 5x minus 48 has to equal x plus 12. And then again, it's just a little bit of algebra. I can subtract x from both sides. 5x minus x is 4x. And I can add 48 to both sides. 48 plus 12 is 60. And then dividing both sides by 4, I get 60 divided by 4, which is 15. Now, we've been lulled to sleep, basically, with answering the question, because all the previous examples have asked us to solve for x. Now, notice that x equals 15 is an answer choice. So there's some bait there. What are we actually trying to find here? We're trying to find the value or the lengths of both sides. So now 15 is not our answer, even though it's an answer choice. We're going to have to plug the 15 back into either one of the original expressions. And take your pick. This one is 5 times 15 minus 48, and this one is 15 plus 12. Choose the easier of the two. So I'm going to use this one here. 15, which is my x value, plus 12 equals 27. Okay? And so the answer is actually D. If you have time, again, you could check yourself and challenge yourself mathematically. You can plug it into the other leg. 5 times 15 minus 48. And 5 times 15 is going to be 75 minus 48, which is, in fact, 27. So again, it's a good check that once we found our x, that we plug it in and make sure that we're getting the exact same answers. Okay, that's quite a lot of examples in a row there. So why don't we just take a quick break and let all that information just kind of stew in our brain, and we'll be right back, so don't go anywhere.
Some of my friends smoke weed and I don't. It's whatever. I drive the car so they won't have to get behind the wheel. I pick where we eat so they won't have to worry about choosing a place. I tell them when we heading out to the party so they won't have to worry about being on top of time or anything like that. And at the party, I'm the one talking to all the ladies. And my boys just sit there till it's time to go, and I'm like, hey, get back in the car, man. But basically, they don't have to worry about living life. I live it for them. Until I go to college, then y'all somebody else's problem. But until then, it's whatever.
Hey, welcome back. Now, I know that wasn't a long break. It wasn't probably very long enough for that information to simmer, but you know, on a 30-minute show with all of the information that I have to cover, we're going to have to do a lot of cooking in the microwave. So let's get cooking again with those triangles. All right, guess what? Another example. Getting good with the triangles here. In isosceles triangle ABC, with a base of segment AC, the measure of angle A is equal to this, and the measure of angle C is equal to that. Find the measure of angle B. Once again, we're not given a diagram, so I know it's an isosceles triangle with the base of AC. So if I'm going to have a choice, I'm going to draw my base on the bottom. I'm free to put it everywhere I want, or anywhere I want, sorry. I'm going to call that point A, this point C, and since it's triangle ABC, the top, which must be the vertex angle, has to be angle B. So again, if this is the base, then I know that this is the leg and that's the leg, and those are the two congruent sides. I'm trying to find angle B, which is the vertex angle. Well, I know that angle A and angle C, the measures are equal. I have variable expressions then for both of them. Okay, so here's one way to do it. I can say that the measure of angle A, which is 3x plus 9, plus the measure of angle C, which is 5x minus 13, plus the measure of angle B, which I don't have a variable for that, has to equal 180. I know that. But I can't do anything with this expression yet because I have two unknowns in one equation. I have x and the measure of angle B. So I'm kind of stuck. I either need to know x to find the measure of angle B, or I need to find the measure of angle B, in which case this problem is done. Well, how am I going to eliminate one of the variables? We're going to actually be able to solve for x first. How are we going to do it? We're going to use the isosceles triangle theorem. Knowing that these two legs are congruent, we know angle A and angle C. I'm using double arcs now because I have one on B. I know those two angles are congruent. So first, number one, I'm going to set 3x plus 9 equal to 5x minus 13. And now I can solve for x. I'm going to collect my x's on the right-hand side. So 5 minus 3 gives me 2x. Adding 13, I get 22. So x is 11. So now, what are the measures of the two base angles? Well, I can plug it into either one of the expressions. I'll choose the 3x plus 9. So 3 times my x, which is 11, plus 9 gives me 33 plus 9, or 42 degrees. So each of the base angles is worth equal to 42 degrees. Now I have something to work with. I know that 42 degrees plus 42 degrees, the two base angles, plus the measure of angle B has to equal 180. Now I have one equation with only one unknown. So 42 plus 42 is 84, plus the measure of angle B equals 180. And then subtracting 180 from both sides, I get the measure of angle B is equal to 180 minus 84, which is 96 degrees. That is the measure of angle B. Now we'll come over here and look at our answer choices, and there it is. Okay? So that one's a little bit tricky. We couldn't just go right to the sum of the interior angles adding up to 180. We had to use what we knew about isosceles triangles and the two congruent base angles to eliminate one of our variables before we proceeded. Okay, another example. If two angles of an isosceles triangle are each twice the measure of the other angle, what's the measure of the other angle? Whoa! There's no numbers or anything in there. Notice that we're missing a picture. So the first thing that I like to do, just to get my bearings, is to draw the picture. I know it's isosceles, so let me go ahead and draw it in the usual orientation with the two legs here. Now, two of the angles are each twice the measure of the other. So I know that these two angles that are twice the other have to be the same measure. So by the isosceles triangle theorem, it must be these two base angles. Okay? Now we're trying to find what the measure of the other angle, which in this case is going to be the vertex angle. I can figure that out now that I have my diagram drawn. Now in mathematics, if we don't know what something is, we can assign it a variable. It gives us a character that we can work with. So I'm going to call the measure of that x. Now I need to write the other two base angles in terms of x. How do I do that? It says that the other two angles are each twice the measure of the vertex angle. So twice the value of x is 2x. So I know that this angle is 2x and this angle is 2x. So now I have all three angles in terms of x, and I know that the sum of all those has to equal 180. So 2x plus 2x, my two angles that are twice x, plus x itself, the vertex angle, must equal 180. So now I add up all the x's. 2 plus 2 is 4, plus 1 is 5. So I get 5x equals 180. Dividing both sides by 5, I get x equals 36 degrees. Now, have I answered the question? I'm calling the other angle x. X is 36 degrees. So yes, in fact, we've got that to be 36. Now, just to check ourselves here, the other two base angles would be twice 36. Well, 2 times 36 is 72. So 72 plus 72 plus 36, does that equal 180? Some quick arithmetic will tell you that it is, and you have now verified the answer. The isosceles triangle theorem. We've been using it all along, but there's something that's nice that falls out of it, something called a corollary. A corollary is basically something that just naturally falls out of a theorem. It's an immediate consequence of a proven theorem, and it really requires little or no proof. There's two important corollaries that come out of the isosceles triangle theorem. The first one is that a triangle is an equilateral if and only if it's equal angular. That means all sides equal, lateral means sides, equal means equal. So if all sides of the triangle are the same length, then all the angles are the same measure. Equilateral implies equal angular and vice versa. The other one says a triangle is an equilateral if and only if each of the angles measures 60 degrees. Well, we kind of can infer that from above. If equilateral implies equal angular, all three angles are the same size, okay? And they all have to add up to 180. So if they're all the same size, column X, we know that 3x has to equal 180, so each of them has to be 60 degrees. Okay? So equilateral implies equal angular, which implies all of them being 60 degrees. Those are the corollaries. Let's look at this example down here now. It says, find the measure of AB and AC in the given triangle. Well, I have triangle ABC, and I know that this angle is 60 degrees, and I know that the other angle is also 60 degrees. Okay, so by the Isosceles triangle theorem, I know that the sides opposite are congruent. So if this side length is 5, I know that this side length is also 5. Well, we know also that the sum of the interior angles of any triangle has to equal 180. If these two are both 60, they add to 120, which leaves only 60 degrees left for the other angle. So 60, 60, 60, this must be an equal angular triangle, which means by the corollary, it must also be an equilateral. So all the sides are the same length. So 5 is the leg, 5 is the leg, and 5 is also the base. So this is an isosceles triangle that is also an equilateral triangle. Pretty cool, huh? All right, now it's time for a random joke insertion in today's program. What did the complementary angle say to the isosceles triangle? What did the complementary angle say to the isosceles triangle? Give up? He said, nice leg. Okay, that's a nice segue into the program, that part of the program we call the Say What? As in, what was that joke all about? Well, today we're going to be reviewing on the Say What portion. Okay? There's a lot of information we've been talking about, and this is just a nice quick way to quiz ourselves here at the end. Number 1, how many sides are congruent on an isosceles triangle? Well, we know for sure that 2 sides of an isosceles triangle are congruent. The third side may be equal to the other 2 sides, in which case we have an equilateral, but we only know if it says isosceles that 2 of them are. So the answer is 2. The next one, what side of an isosceles triangle is not equal to the rest? Remember, in an isosceles triangle we have 2 congruent legs, and those are the 2 that are equal to each other, so the answer is they may not be equal to the third side, which, remember, is the base. Okay, so the base, which is not necessarily the bottom, but it's opposite the vertex angle, may not be congruent to the other 2 legs. All right, number 3. Besides the 2 legs in an isosceles triangle, what else is congruent? Well, let's draw the little picture again. We know that the 2 legs are congruent, so by the isosceles triangle theorem, the 2 opposite angles are congruent, and we have special name for those angles. Remember what they're called? They are the base angles. So in an isosceles triangle, the 2 base angles and the 2 legs opposite the base angles are congruent. How many sides are equal on an equilateral triangle? Well, again, equi means equal, lateral means side, so all sides are the same length. And there's how many sides in a triangle? 3. That was a pretty easy one. Number 5. Are the angle measures different in an isosceles triangle? Are they different? Well, the answer is yes and no. Remember, in an isosceles triangle, we have at least 2 angles that are equal. So these 2 base angles have the same measure, but they may be different from the vertex angle. They may be. Most of the time they are, because in the case where all 3 were equal, we would have an equilateral or an equal angular triangle. So in general, 2 are the same and 1 is different. 2 same and 1 different. Okay, the 2 base angles are the same and the vertex is different. All right, what is the measure of an angle in an equilateral triangle? Well, equilateral, remember by the corollary, implies equal angular. So there's 3 equal angles, and they have to add up to 180. So x plus x plus x has to equal 180. So 3x has to equal 180, and we know that x has to be 60. There's no other option for the angle measures in an equilateral or an equiangular triangle. They have to be 60 degrees. That's part of the corollary. All right, number 7. If we're given a triangle that we know to be isosceles, and we find that one of the base angles measures 60 degrees, what conclusion can we make about the triangle? Well, let's look at it. If we are given an isosceles triangle, this one here, and we know that one of the base angles is 60, okay? The base angle is important because that means that this side is congruent to this side, which means that this angle is also 60. So if we know that two of the angles are 60 because one of the base angles is, then they add up to 120, which leaves only 60 left for the vertex angle to get to 180. So what conclusion can we make? We can say this is an equilateral triangle. Now remember from a previous show, an equilateral triangle, since all the degree measures are less than 90, all equilateral triangles are also acute. Okay? The next one. If we're given a triangle that has two congruent sides and one angle measure of 70 degrees, what type of triangle is it? Well, let's draw it out. Two congruent sides. So again, the most easy convention to draw is this one here with those two congruent sides. So it appears that we have an isosceles. If one angle measures 70, it doesn't say which one. So if this one was 70, we would know that that one would also have to be 70. And so those add up to 140, leaving only 40 degrees for the vertex angle. So that would be one possibility. That would be an isosceles triangle and would also be acute. But what about the other scenario? What if 70 degrees was the vertex angle? Then that would leave only 110 to add up to 180 for the two congruent base angles. So they would each have to share the 110 evenly. So that would be 55 and 55. So we would have those two possibilities. But notice that in each case, they're both isosceles. And since all the angles in each of them are less than 90, they're both going to be acute. So we can actually say that it's going to be an acute isosceles triangle. Okay? Given a triangle that is equilateral and that one side is 20, what are the measures of the other side? Well, that's easy. Equilateral means all sides equal, so they all have to be the same length, which is 20. So they don't get harder as we go along. One last one. We're almost done. One of the base angles of an isosceles triangle measures 45. Let's draw it. These are the two congruent sides. Here's the base. So if this is 45, then what does the vertex angles measure? What is that? Well, if this is 45, then we know that one's 45. 45 plus 45 equals 90 degrees, which leaves what left over to get to 180? 90 degrees itself, which makes this triangle, what type of triangle? A right triangle. And what type of right triangle? It's an isosceles right triangle. And that's a pretty cool triangle. Well, guess what? It's time of the show where we're out of time. I wish we had more time, but it's time for me to be leaving you. I hope you learned a lot today, and remember that if you ever have any questions about today's lesson or any other lesson, feel free to email me at kcorpy.newbraunfels.txed.net, and I will get back to you as soon as possible, I promise. Until next time, I am Kevin Corpy, and I will catch you on the flip side.
You're watching Channel 98 NBISD TV.